now by Henry Guo, VP of Product at Prove AI. And we are going to get to Prove AI, I promise. Before we do, you have a very interesting journey with AI machine learning, and I would love to hear just kind of where your journey has been so far, and eventually how that led you to Prove AI.
Great, and thanks for that, Sinan. And my journey started, let's say, VMware, and I transitioned to another company called Petrum. It was founded by a CMU, Carnegie Mellon professor, with the idea of how do you change AI everywhere. That was his vision. It was 2018. That was the onset of AI. AlexNext is taking off. We're really doing computer vision, and that's how I got into it. And I got super excited. We got $93 million from SoftBank. We were going to change the world with AI, and we did a lot of great things. And that was my first foray in AI. And now we are in the era of generative AI. Back then, it was still traditional AI. We actually played around with ChatGPT 2. We looked into BART and all those other ones back in those days. What actually we hit it upon was industrial AI. We actually did optimization, and 10 of us split off from Petrum called OPRO AI. We're actually working with the largest oil and gas companies in America doing industrial automation using time series data. And that was one of the really interesting applications because we actually designed it, built it, and running actual oil refinery production. And the yield you saw was actually much, much better than humans. And that was my first foray. Like, how do you do traditional AI? And from there, you see a lot of VC articles and we kind of the exact same thing. AI at that time was still very much a adaptation. How do you take models? How do you then work with the customers? How do you clean their data? How do you finally put that into production? And that was a lot of learning. And from there, I transitioned to the company called OmniML, founded by an MIT professor, where we really tackled compression. How do you compress AI algorithms to make it fit into self-driving car companies, robotic companies? We worked, one investor was Qualcomm. How do we make sure it fits into some of these, what's called robotic for the factories? How do we do that? And what we did was a neural architecture search. We figured out ways to find a best fit within this neural architectures, given the latency and the hardware, and we stripped away operators that didn't work. And then we actually live, and we have 3 or 4 of the top EV companies, and then NVIDIA came in and found out our technology was, wow, this is awesome. This is something that they can use, and acquired us back in 2023. Why I'm getting into this to prove is I come from a very traditional computer science, AI background. Now at Prove, we're tackling this in a very different angle. We are historically an enterprise blockchain company, but my role is how do we actually implement AI into this blockchain? This blockchain itself has a lot of tamper-proof distributed ledgers and writing into it and using smart contracts and so forth. But AI inherently has a lot of non-deterministic. How do you then have a guardrails and this governance around it? And that's my role in building this new product for it.
Okay, so thank you for sharing that, because I think it's really important though, because with a lot of these journeys with AI, a lot of the times people are coming at this from obviously different angles. A lot of people who were not in AI before, machine learning before, who were getting into AI machine for the first time. But not only have you been working in AI machine learning for a long time, you've specifically been working with kind of smaller research-oriented institutions and businesses, focusing on not just what is AI going to do for me, but also how do we actually bring out the maximum efficiency of these systems, whether it's for something in a robot on a factory floor or it's for some kind of NVIDIA-based purpose. Thank you for saying all that. So my first question then, kind of kick us off here, is you've probably seen several dozens, if not hundreds, of AI implementations throughout your career. Most companies, especially enterprise companies, are dealing with gigantic data sets, often unstructured, and frankly, for the most part, just sitting in some data lake, data warehouse, whatever we want to call it, and they're just now realizing it's time to make this data actionable. The time is now to actually use this data to actually bring it forth into the AI systems and actually make it usable for our customers, for our clients, what have you. What have you learned, and what advice would you give to people just now figuring out how to deal with these massive structured data sets?
Start early and have policies and understanding around it. It's not, traditional AI really took a lot of this kind of messy data, had to clean it up and get it ready. The interesting part about generative AI is you have these massive models where you cannot maybe get to 100% from day one, but you have, by building these foundational models, you can get a lot done, right? So there's that element that's already changing is on its head with the idea of generative AI versus more the traditional one where you take data and then you train a model and then you put it in implementation. Nowadays, you're doing a lot more fine tuning or prompt tuning, something like that, right? So understand where your data is and get it clean and understand what data you need and then what data you don't need. And from our Prove AI, our software product takes that understanding. We track the data provenance of when that happens, and then we see which data sets are going to which models. So if there's a change happens, we actually see the hash value change. So then we can, hey, track that. If something, an output, like you're doing a chatbot, right? You're doing customer service, suddenly it's spewing out hate speech. You know which data set, if you're doing a retrieval augmented RAG implementation, which data set might have done that weird trigger, and then you can actually go back. And that's the idea with Prove AI is we can see, track it, and figure out what that is, so you could triage and actually, change it back, roll back to a previous version that doesn't had all the hate speech that's being spewed out.
So you brought up a term which I love, by the way, provenance.
Yes.
Provenance, not only for the art market anymore. Provenance, the idea that you are able to kind of track not just data, but also kind of model inference. And,
yes.
and it's not a new idea per se, right? We've had things like feature stores, model stores, the idea that you would be able to track your data provenance through some open source or closed source technologies. We've had that for a while. Tell me about what makes the blockchain a really useful technology here, and kind of to follow on, what is Prove AI doing that is really different from the market in terms of data and model provenance?
Right. I mean, this is, you touched a good point. I mean, data provenance has been somewhat around. There's been other tackle.
Promises, at least.
Yes. I think the blockchain angle gives the idea of one's tamper-proof. Once it's written to a blockchain, it's written to a blockchain. We, of course, use encryption to make sure only the right people can access it. And one of our key areas where we bring in auditors. So by sharing a certain key, auditors can actually go into the secure blockchain and actually see some of the encrypted data that does with the provenance. I mean, I think the inherent nature of blockchain rounding finality, serialization gives that element that you can do with a database, right? But if you make a tamper-proof database, it's very, very. It takes a lot of time and effort.
It's iffy at best. I would argue.
Yes. So the interesting part about blockchain offers that as a feature of it. There are, of course, trade-offs. You probably don't want to use blockchain to train data because the way it handles consensus, you have to go out to messages and come back. That's just a lot of wasted. But the way to actually use it as a kind of an audit tool and see the lineage, and every time that changes, you write into a blockchain, you can actually then trace it back. And that's our thesis and our vision for it. And it seems to be proven somewhat with our early adopters.
Well, on that note, if you can tell us some about the early adoption of this blockchain technology for AI inference, Again, the promise to me is quite obvious. The idea that you can track not just training data or what have you, but when an AI does something that you want to be able to audit, can you track it back to the offending document, or whatever that might be? Tell us about some of the early adoption, not just what's going well. What have been some of the obstacles in this adoption, either from a technological standpoint or from have you seen issues with people having to go through legal scrutiny, or what have been some of the hurdles in adopting this technology?
Yeah, I'll go. One of our early adopters is using computer vision to food inspection. Very
food inspection. Okay,
very interesting, right? Okay, yeah. You don't think about that. So we all eat cheese, potato chips. Before you have metal detectors, and then you move to X-rays, and you see those
metal detectors. Sorry, I'm learning about this for the first time.
I'm learning about this too. Okay. We're talking about somewhere between.
I mean, I'm glad, I guess.
1,000 to I heard our customer partner saying 200 cans going through these things. Well, because what do you have? I didn't learn this too, thank goodness. But it's you have bones. you have metal wires. You have things that can go into chicken nuggets. Things that go into potato chips. If we're going to Costco, we're going to buy that. I don't want that in my food.
Same.
So what they're doing is now, before they used the metal detectors, but you're going to miss bones and so forth. So they're using an innovative machine that's actually scanning all this at real time and using computer vision to detect if there's any foreign objects. Mm-hmm. And what they also do is every, 30 minutes or so, they do what's called a challenge test where they put something where they know this so it doesn't give you false positives. So what are we helping with them is we track which data set are going to train these models. So then these are the computer vision models. They don't change too much, but we help them to do this kind of management, and then we know when these is happening. And post that, one of our kind of early pilots with them is when these lots are happening, we actually see the false, it's a positive detection or negative detection. We actually put that onto blockchain. So therefore, if something happens, you can trace it back to lot number. So if there's a recall, you can see when that's done, right? These are just things that you don't think about, like food inspection. But food inspection now is also using AI to detect foods the same way, of course, probably not so much as like breast cancer or something like that levels, but I'm actually feel a lot more comforted that we're using technology to do this type of detection because we're going to have hopefully less recalls in these packaged goods.
One thing that stands out to me is that a lot of the conversations these days about AI generally comes back to generative AI, right? Well, the idea that the biggest breakthrough in at least natural language technology has been the transformer, which led to generative AI and both non-generative AI like BERT and what have you. But food inspection sounds, at least to me, more like a computer vision task, which is not generative. So it sounds like this kind of technology can be used both for kind of the modern generative AI, but also the more classical ideas of image classification, object detection.
Exactly.
Right? Does that sound right?
Yeah,
Is that right? What are the other types of tasks that are really provable to be used on that system? Like what is a good? What are good use cases?
This is a very good question. We actually built this more on the idea because we started this journey more about like 10 months ago with generative AI, but we can capture metadata associated with traditional. That was just the early use case that came to us. The other one we're talking with another customers is the typical code review. So
what is it?
Code review.
Code review.
When people are programming and they're reviewing the code. This is mostly for
code. I heard cold review. I'm like, interesting. Tell me more about
code review. They're typically using LLMs to do code review, right? And what's interesting, we have a strong partnership with IBM. Our ML ops is being powered by what's called the Watson X, and they have they have access to the latest Llama 3, Mistra. They have their own what's called Granite Series model, and we're helping them do testing. Prove AI has a thing called Prompt Playground. It's what you would expect a generative AI output to have. So you have a way to do a sandbox, right? You can change the different top K, top Q, top K, top P. If you want to do greedy, if you want to do sampling size, so you can change the amount of tokens to have that context. We actually built that with the idea that our first couple use cases will be generative AI, which we're starting to right now implementation. The first one was more traditional computer vision. So we set different metadata. Is this data going to be from a RAG database versus a traditional database? Is it going to be a more computer vision where you have tags or associated with that, or LLMs? So for Prove AI, we are working with a very, very early days right now, kind of scoping out is if using LLMs, can you then, we put that into Prove AI, and then using the IBM as the ML Ops platform, we can then actually run these, and we save each of the contexts. You could load and save all these different ones, so you can see the provenance. Once you track the data and the model, we also want you to use our platform to test it, right? To actually see if these LMs are performing wacky, right? Hopefully you capture all the hate speech and stuff before it goes live, right?
Is this where the auditors come in, or tell us about the philosophy of evaluation of these systems?
We're both internal and external. We are targeting internal compliance teams. Right now we did a research project. We talked to quite a few Fortune 500. There are now what's called VP of AIs who report directly to the CEO, and then under him he had a 40 people team doing AI governance, and the whole idea is just do testing. This is actually very prominent in the insurance and banking industries because they've done models already, quote unquote, right? Now they've changed in generative AI, so they have these internal compliance teams, and we want these guys to use our software to test it. And another thing is we're talking with some of the auditors. If you think about KPMG, Deloitte, some of the other ones. We want them to be also a user, not a customer, but a way from them to come in and actually audit with ours. So there's ones in the AI governance space, maybe we'll get to later on. The major ones right now, the EU AI Act, Colorado has a new one, and then there's another standard called ISO 4201 is the kind of one of the major ones for standards for AI systems, security, and then NIST ones. So we are implementing these type of legal regulations in there to track to see, hey, how close are you with this? Are you actually on track? And that gives the auditors capabilities to upload artifacts associated with it, and finally afterwards to hit a test. And that's the power of blockchain is once you test, we actually write down the chain that, hey, this auditing company, so you know that. And if a hash changes, then the testament technically goes away. And we believe this will be actually hopefully we never get to that point, but if you have to go to court, that testament and blockchain gives that higher legal backing than a normal database that could have theoretically been tampered and changed with.
So governance,
Yes.
you said it yourself. It's funny, when I talk to people about governance on an interview or whatever, there's either two ways people look at governance.
Yeah.
It's either moving so fast it's hard to keep up with, or it's moving at a snail's pace and we need to do more.
Yes.
These are generally, and I think the reason why is, you kind of said it really well yourself, which is you're talking about something in Europe, something in Colorado. So you're talking about both at a continent level and both at a state level. These kinds of governance and regulations can happen almost at any moment at any. Go ahead.
No, we were at an NVIDIA conference this previous GTC, and we had good people from U.S. Congress coming in. They're writing laws, but they're trying to, right? I think at the federal level in U.S. it's tough. You have all these inputs, so that's why you see states moving faster.
Exactly.
You moving faster.
Exactly. So when people say it's either moving too slow or too fast to keep up with, I think that's really the juxtaposition.
Yeah.
Which is, depending on where you're looking, where is the regulation coming from? So my question to you then is, with Prove specifically, how is Prove helping customers, clients, users navigate the kind of either rapidly evolving or snail's pace evolving world of governance? And specifically, how does that help your customers improve their transparency and security of these AI systems?
Very, very relevant. So the way we look at it, and I think it's a good analogy, and let me know if you think so too, our CEO mentioned this, is we kind of provide the seatbelts. And there's studies, if you have safety seatbelts, you actually drive faster, because in case something happens, your seatbelt can protect you. And that's the idea we have, right? We are providing a layer of safety seatbelts. We don't want to slow down. Like, you hear a lot of people on one side, hey, we're moving too fast, Terminator's coming in tomorrow. The other side is AI is going to change the world. We're going to have essentially overabundance, right? I think I personally, being in the AI space, closer to, hey, AI can change quite a bit of things. But let's put some guardrails, some safety belts around that. And that's the whole idea of Prove is, hey, we know you want to move fast. We know companies are trying LMs. We know, the ones we hear a lot is coding review, programming review. Of course, the help desk tickets. Surprisingly, given the idea of GPT, you would think a lot more people are going to do kind of this customer support, kind of this, hey, open chat. But there's a hesitancy, I don't know if you've seen this, and large companies adopting that because they don't want these LMs to just go wild and start.
Right.
So we are hoping to provide
that trust. It's that trustworthiness aspect.
Yeah. Versus if you look at it like programming reviews, and then internal help desk things. These are internal. You're not going to expose customers to it. So there's why I think building these seatbelts can allow these people to feel more comfortable putting into these customer supports, customer help desk things. And that's exactly what Prove is looking to do. Is we are going to say, hey, you've done your best. You're tracking the data sets. You're tracking the model. By working with IBM, they're very great about this. Is does it have PI information? Has it gone through a hate speech filter, which IBM provides through their software? Right. They're all about training their data on copyright-free information. So we actually have these metadata associated with it, so we know which data's, as far as we can verify. We can't verify everything, but if the ones we know, these data sets are cleaned. We're now talking with other companies who've looking to do security audits of, not audits, but security through Hugging Face. So Hugging Face, everybody's kind of uploads models. Most of the ones from larger companies you could probably trust, but once you fine tune it, there's ways you can inject Trojan horses to viruses. So this company is looking into, can we scan this? And if they could, can we become that trusted, say, we can do that stamp approval. We have this kind of blockchain to back that these models are been scanned and they're cleaned, right? So I think with a lot of these elements put into it, there's going to be more trust in the AI. And going back to the output of a LLMs using RAG, we are very, very much into this thinking is if you implement RAG, you need to know when updates that the RAG has changing some of the parameters to the prompt areas to the LLMs. We actually track each of these ones through Prove AI. So when that happens, we can go know which version it is, right? So part of it is one, we can put in guardrails. You shall not do this, and then fairly we have the sandbox to test that before it goes live. And two, should anything happen, we can quickly triage and roll back.
Roll back if necessary. Yeah. Prove AI, building the seatbelts of moving fast with AI. Does that sound about right?
Well, we think of it as like kind of, I hate to use overterm the co-pilots, but we're kind of thinking we don't want to be a hindrance. We don't want to be the people saying, stop, don't do this. We're the AI police. No, we're thinking about if you're building this, that's the working assumption. What can we do to make sure you hit the speeds, but with a layer of
knowledge, context.
Yeah.
What are you doing? How can we help you move faster while keeping in line with regulation, governance, and all that? Does that sound
exactly
nice?
Yeah.
Okay. Well, Henry, thanks so much for being on the show. This has been a wonderful conversation, and we look forward to seeing what Prove AI has for us next.
We're going to have major announcements next week when a lot of us are going to be at IBM Tech Exchange, and it'll be a lot of interesting announcements. So hopefully we catch up afterwards.
Sounds great. Well, we'll be on the lookout. Thanks so much.
Thank you.